Chapter 5, Section 2, Factoring Trinomials of the type x squared plus bx plus c. We see a lot of these types of trinomials come up in a lot of different ways. So this whole section is going to focus on strategies really to focus on these types and find strategies that will hopefully make factoring less steps, less chances for error. Again, a lot of this is about strategy. We're really just expanding on patterns created by the distributive law. And if we said, okay, we're going to go just take every type of trinomial and factor about 500 of these things, you would start to see some of the patterns they're going to show you now. And basically that's what's happened with a lot of these things. They say, hey, look for this, or think about these things in reverse. When we multiply, we ended up with some special multiplications that have patterns to them. And really that's the reason we really focused in on the patterns on multiplication, like FOIL and difference of squares and squared binomials, those kind of things, is that hopefully you remember the pattern, and then when you see the pattern in these resultant polynomials, you'll be able to recognize a good strategy to factor. So we're going to have when a constant, when they're going to talk about when things are positive and negative in certain cases, and really it's just strategic things to look for first. There's really an order to problem solving we need to focus in on. I see a lot of students have prior ways of problem solving that have worked, and they get in trouble because they skip looking for certain things. So we're going to look at our strategies. We're going to talk about what prime really means. Again, prime means it has itself and one as a factor, or just two factors. When we have things added, and those kind of things, we need to think about what factors are and what additions are terms, and then we got to make sure we're factored completely. So to look at examples again, and that's exactly where they go to, is really some stuff we've covered already. Again, they're talking about, hey, let's look at this FOIL thing. When we have a binomial times a binomial, we have certain things that are patterns in this. If we have a positive, an addition times an addition like this, they want you to see that that we get this FOIL, we combine the like terms in the middle. That's why they do this order. But also notice that there's there's always a positive sign here and a positive sign. They're starting to look at these kind of things. If I have a subtraction times a subtraction, in other words, the second term in my binomial is negative, it'd be like same as x plus -2 and x plus -5. We end up with this middle term being a negative and the last term, the constant term, still being positive. If I have an addition and a subtraction, I end up with both my middle term being negative and my last term being negative. And also it could happen this way. Here I have a subtraction and an addition, and I end up with this last term being negative and my middle term being positive. Now, if you start thinking about those in terms of this, things that they're going to show us for rules or ways to try to illustrate this, when I have a negative last term, I'm looking for a difference between these two will be my coefficient of this middle term. Now, what I would say is you add them. I'd say difference is a bad word for that. If you think about this as these terms as addition, this is +3 and -7. Well, when I add those together, I get a -4. Same thing here. If I had a -2 plus a -5, I get a -7. 2 plus 7 is 7. So on. So I think they emphasize a little bit too much about the pattern stuff, where this stuff is really all the same. Uh, when we think about, how do we get this middle term? It's the sum of these, the O and the I. So the 5x and the 2x, negative 2x and 5x, and so on. It really is the same pattern, but it does help to think about them in those ways. Might help you remember to make sure you get your signs right, especially. So it says the product of two binomials is a trinomial. The coefficient of x in the trinomial is the sum of the constant terms of the binomial. In other words, just what I said here is that this middle term is the sum of these two times the variable, and so on. The constant term in the trinomial is the product of the constants here. So I get this 21 by negative 3 times 7, and so on. So they're really, this shouldn't be anything new. They're just saying, hey, let's think about maybe some patterns that we can see to help us be able to factor these more easily and faster, less steps, less errors, right? And so it says when a constant term is positive, like this one, this is a constant term in this case, which is 10. I'm going to end up with, and the first term is x squared, so I know I have an x and an x to get this first term, which is first times first. And then I know that the 10 has to be two numbers that have a product of 10, or factors of 10 are going to be my possible deals here. Now there are 4 factors of 10. I can take 1 times 10 and 2 times 5. So I need to find the combination of factors that will create this sum that I need of 7x. So that would be 2 and 5, and so on. You factor this one completely. In fact, using anti-FOIL, a lot of times this is called anti-FOIL, is I take the first term, how do I get an x squared? I put the x in the x, then I have the last term is 6. Well, there's 4 factors that can give me 6 as a product, 1 times 6 and 2 times 3. And then I think, well, 2 and 3 add up to 5, so that's going to be my process of putting that in here, and we'll finish that example. I'm going to come back to this diagram here. This is a very good visual way to look at some of the things that are going on with binomials, and we'll come back to this several times in different parts. So this modeling, or basically drawing a picture of an area of a rectangle, illustrates some things for us that we can look at in the process here. So I'm going to come back, but let's finish this example here. Example 1. And they list the factors of 6, and the other ones I didn't talk about is, yeah, there's actually more factors. Negative 1 times negative 6 has a product of 6. Negative 2 times negative 3 has a product of 6, and it's easy to forget these negatives. So these are all factors, and then I look at what is the sums of these things. So if I had 1 and 6 as my constants in my binomials, my sum of the middle term would be 7, and here's one that adds up to 5, and I kind of talked about that already. Now if I had a negative middle term, I'd be looking at these negative constants for the binomial. So basically we pick out this. I really doubt in these simpler ones that you're going to draw all this out. It wouldn't be a bad thing to make the table, actually do the written work like the examples, not every time, but I think if you do this a couple times on your own on an example, it's going to really force you to really think about the process, because that's what's important here, is the process of using a strategy, understanding the pieces of your strategy. So actually practice it on paper, just like you're taking notes in a history course, those kinds of things. I think that's one of the things that's most forgotten in algebra, is that we tend to look at all our notes in a book which is really trying to illustrate all the concepts and strategies that we're going through, but we actually don't write those things down. And I don't push notes, or I've never been around math teachers that really push taking notes in class, because really you take your notes as you're working on these problems, working on the problems in the way and the method that they're trying to get you to learn is the way to do your work for these assignments. And the other caution is you're going to find some other ways to do some of these problems, and you might skip to that possibly better strategy, but you're still going to need this strategy for certain problems. So it's very important to understand the process we're going through, or the steps. So they take that through there. Now let's look at this diagram of a rectangle. Again here, this geometric approach to example 1, which is this x squared plus 5x plus 6. You know, as we search for this p and q, the constants in the binomial, well, we know that we're going to have x and x. Well, here's my binomial. This length right here is x plus p, and this length is x plus q. Well, if I multiply these two things, I'm going to get the area of this entire rectangle. So we kind of know what A is here. That first area is going to be x squared, right? So when we go through this process, they're really talking about here, we ended up with factors of 6 again, right? Which were 1 and 6 and 2 and 3, negative 1 and 6 and negative. Well, when they're positive, and that's why they want to show a picture of this, it's pretty hard to draw a picture when we have actual negatives that occur, which, how do you illustrate that negative distance? It gets a little tricky to draw a picture of. So this is the model. So if I took, let's say I decide to try the factors 1 and 6. Here's my binomial, x plus 6 and x plus 1. I actually fill that in and then say, let's look at all the different rectangles. What would I get here? Well, you'd have this x squared here. What is this box right here? The area of this is 6. Well, what's the other length right here is x, right? So the area of this is 6 times x for this rectangle. The area of this rectangle right here, well, this side's 1, and what's this side? It's x, so that's 1x. And the area of this here is 6. Well, that works for the 6, right? That's the last term of my binomial right here is 6. But these two I can add together, these two areas, because they're like terms, right? So I end up with x squared plus 7x plus 6. Doesn't get me back to the original. So when I try this again, these binomials, and I try the factors 2 and 3, I get x squared, here's my 6, right, my constant, and I get 3x plus 2x. Very nice tool to get a visual on what's going on with this multiplication of binomials. This area modeling is a very nice thing to hook into to get a visual. Like if you can draw a picture of a word problem, you always do. Well, we can draw a picture of what's going on with this factoring in a sense, and to check this. Now it says to factor when the c is positive, the end term here, when they're talking about these letters, this is the last constant term of my trinomial. We have this instance. They basically illustrated what we went through in the example. Well, I could have positive constants here in the binomial, and I could still get a positive here. But you got to remember, I could also have negatives, still get a positive here. So we need to consider. In fact, that's our trigger really to say, hey, I'm going to probably, if this is positive and I have a negative middle term, I'm going to have negative factors of 12. And that'll save you time, rather than like in example 1 we listed all the factors of 6, which are 1, 6, 2, 3, negative 1, 6, and negative 2 and negative 3. Okay, so this is what they're trying to really illustrate in these examples and how they set up the order of these examples has a purpose too. So, hey, if I see this one's negative and this is positive, I know I have two negative terms for my constants of my binomial, and that'll save time on the amount of factors that you're going to have to deal with. Like 12, I mean, now we're getting into things that there are four negative factors of 12. Well, there's four positive factors of 12 too. So we're looking for ways to strategically narrow down how many things I need to experiment with to find the right sum for that middle term. Okay. Now, when the constant is negative, again, they're showing this is really pattern stuff. Again, you could find all the well, actually, there's less. Well, there are quite a few factors of negative 21. Remember, we're talking about terms again. Even though it's subtraction, terms are parts of an addition. So this is really plus negative 21. And so we're going to be looking at, to get a negative 21, I got 1 and negative 21 are factors, negative 1 and positive 21, 3 and negative 7, and negative 3 and 7 are possible factors there. So what we need to do then is, if I look at this middle term, I need the sum to be, in this case, a negative 4. Well, then I know that this one with the larger absolute value, or the one that's farther from 0, will be like the 7 here, right? Needs to be negative for that sum to end up negative. And in this case, where it's positive, the one that's farther from 0 needs to be positive to do that. Okay? And this example 3, when I have negative, negative, right, I'm going to end up with choosing the one. Like, I could have had another group of factors that give me negative 20 or negative 2 and positive 10, but that would add up to a negative. So they choose the factors that have the bigger or the larger absolute value, which means distance from 0, has a larger distance from 0 as being the negative. That way, when I add them together, I know I'll end up on the left side of the number line, right? And stay in the negative region to get a negative sum. So we look at this, and they're showing basically finishing that, and then basically this describes just what I went through. It says if the constant term c is negative, look for the positive number and negative number that multiply to that c, or in other words, the factors are positive and negative. Consider only pairs of numbers for which the number of the larger absolute value has a sign of b. Now b is the constant for that middle term. In other words, if the sign is negative, we look for the larger absolute value, or the one that's farthest from 0, being negative. If b is positive, the one that's farthest from 0 would be positive, and so on. And that'll save you steps and math checking, all that kind of stuff. And these are really the differences about, you'll have maybe somebody you're working with. Hopefully you get to work with somebody on some of this homework sometimes. Usually somebody in your same class. It's a good idea to, you're on the same boat, that you work together on some stuff. Not a bad thing to do. But you'll see some people that do this, that just bang, bang, bang. They just kick these things out. Well, they're used to applying the strategies. They think about these signs, they think about factors and sums, and they do a lot of this work in their head pretty quickly because they understand the strategy. Okay? If you're not one of those, then you probably need to write this out a few times as you do your homework, and then I think you're going to remember the strategic things that they're trying to illustrate in this section. Now, in this case, now they're going to get a little more complex, where they have a squared plus 4ab minus 21b squared. You need to think about what's going to create my first product here, right? The answer to my multiplication of two factors. in this case a squared, well, it's going to be a and a, right? So I know the first part of my binomial is a and a, okay? Then I have this part here gets a little more complex because I got another variable in here, which I have a negative 21b squared. Well, what are factors of 21b squared? And I could list those factors, negative 21. And that's what they're trying to show here. You say, well, our process is, well, I know I need a b and a b, so really I just need to focus. To get the b squared, I got a b and a b, and they say these p and q's, don't worry about that right now, but remember that to get b squared, I have to have in the binomial a b as part of my term of my second term of my binomial, right? Okay, so really if I see that and I realize this, the process is the same. I'm just going to work with that negative 21 to find factors of negative 21 that'll give me a sum of 4. Now this might throw you a little bit because really what I have is not 4b or 4a. I got 4a times b because we're going to have, you think about FOIL here again. I'm going to have inner is going to be some number b times a. I'm going to get some constant times ab because I usually put it in alphabetical order. And then the outer times outer is a times some number times b. I'm going to have this middle term is going to be a times b will be my like term. So we find, going back to this now again, we find factors of negative 21 that will add up to 4, and which would be positive 7 and negative 3. And then check. We didn't talk about the checking too much, but as they get more complex, it is definitely worth the time to check. I'd hate to have to do a lot of complex work, do a lot of steps, and make a math error or some simple error. Make sure you check this, and you can multiply back. Usually the multiplication is a little more straightforward. We should multiply back to the original trinomial. Now prime polynomials, prime again means that it has two factors, right? So let's look at this one where we have x squared minus x plus 5. Now since 5 has very few factors, we can easily check all possibilities. So they don't go into any kind of strategies yet or anything else. Let's just look at factors of 5. And I end up with 5 and 1 is possible factors, or negative 5 and negative 1. Well, the sum of these factors is 6 and negative 6. And I look at that, the only way that I could factor this into two binomials is that this middle term has to have a sum of either 6 or negative 6. And it has really a negative 1. Since there are no sums that will make this middle term right, I know that this is not factorable. Or in other words, the only factors of this trinomial are 1 and this whole thing. It has two exact factors. That means it's prime. So in this case, that was pretty easy to check, okay? So we need to look at this. This can throw us. I mean, if we're not really good at the strategies of these types of trinomials, when we see them and they throw a prime especially in a test, I can see how much time each student spends on a question. We go boom, 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 1 minute, 2 minutes, and all of a sudden I'll hit a prime one, and I'll see, maybe 10 minutes on this problem, because you just have trouble believing that you can't factor that anymore. But that is definitely a possibility. The other issues that come up are